Permutations. Before we talk about permutations, we need to talk about factorial. The exclamation mark means factorial. So when I read this, it's read as n factorial. And all it is, I'll use an example to explain it. If you see like 4 factorial, it just means take the 4 and multiply it down. So take 4 and then do times 3, times 2, times 1. So you go start with the number that's given, and then multiply down. 4 times 3 is 12, 12 times 2 is 24, and 24 times 1 is 24. Now most calculators have this key. So on this calculator, it's right there. So if I hit 4 and then that factorial key, it does it for me. On a graphing calculator, if I hit 4, I need to go to math, then I need to go over to PRB. I can go left or right. If I go left, it's faster. There's the 4. I can move down, hit to 4, and hit enter, or just hit the 4. And it brings it up for me. Then hit enter. And we're going to use that to do permutations. Permutations is the number of ways to choose so many items from a bigger set of items. The main thing to remember is the order is important. Big deal. The formula is given to be n factorial. Well, n is a bigger number, so we're choosing r items from a set of n items. So n is going to be the bigger number, or the same. R is going to be less than or equals to n always. So the formula is n factorial over the difference of n and r, n minus r. Get that answer and then find the factorial of that. So we're going to find 5p2 using the formula. Then we're going to do it by calculator. So to do it by formula, you have to recognize that this is the n and this is the r. So it's going to be 5 factorial over 5 minus 2 factorial. And then that's the same as 5 factorial, and 5 minus 2 is 3 factorial. And you can do this by just doing 5. We need some space. This is going to be a short or a longer way of doing things. Let's just come down here. So 5 factorial is 5 times 4 times 3 times 2 times 1. And 3 factorial is 3 times 2 times 1. What you can do is, if you want to, you can multiply that out on top, multiply that out on the bottom, and then get the answer that way. Divide them out and get the answer. Or you can do this. These 3's cancel, these 2's cancel, and 1 don't really worry about too much because they equal 1. And 5 times 4 is 20. And you're done. Now most scientifics have a key like this. It may look like NPR, or it could be something like this. It's the same thing. This calculator doesn't happen to have one, but I can still do like 5 factorial divided by 3 factorial pretty quickly. Hit equals. Now most calculators have one of these two keys. And the graphing calculator does. If you hit math and go left, you'll see it, NPR. To use that, what you do is you hit the 5 first, 5, and then math over, and then 2, which brings up that key, and then hit that 2, which represents the R, and hit equals, or enter. And you get the 20 that we just found. Nice, isn't it? So let's look at a more concrete example. Suppose you're given 3 letters, A, B, and C. We want to find the number of permutations of 2 letters at a time. So that just means we're going to list them. We could actually do it as 3p2 because we got 3 total. We want to choose 2 at a time. And if you want to do it by hand, we do 3 factorial over 3 minus 2 factorial. 3 factorial is the same as 3 times 2 times 1. And 3 minus 2 is the same as 1 factorial. So that's 3 times 2 times 1 over 1, which is 3 times 2, which is 6. Once again, if you want to use your graphing calculator, your scientific, and you want to use that key, you just hit 3 and find that symbol, NPR, and then choose 2, This will be the same way scientifics will be done also. Enter, and we'll get to 6. Now, let's actually list them. So from our list them, so we can choose A and B together, and then A and C together. And then we choose B and C. With permutations, the order is important. What that means is A and B is not the same as BA. It's a different ordering. A and C is not the same as CA, and BC is not the same as CB. So these are all 6 different orderings. 6 total. That confirms what we just found. See that? Permutations, order is important. Now let's do some real life examples. We have a 12-person committee or community group, and we need 1 person to direct the play, a 2nd to supervise, a 3rd to handle publicity, tickets, and other administrative details. And how many ways can the group fill these positions? Now notice it says 1 person from the group to direct the play, and a 2nd person, and a 3rd. That's 3 different people. 3 different people. 1 person can't do all 3 jobs. So when you think about this, today you may have a lot, Susan direct, and then John supervises, and then Elmo handles everything else. But then the second day, Susan may be the person that supervises, and John may be the person that directs, and John handles. That's a different ordering. See that? Different situation. And then another day, Elmo may be the one that directs, and Susan does supervising, and John does handling. So there's all kinds of possible arrangements here. So what that means is order is important. What that means is it's a permutation. So we got 12 people total. And how many are we going to choose? 3. 1, 2, 3. So it's going to be 12. Out of the 12, we're going to choose 3. So it's going to be 12 P3. And all I'm going to do this problem, I'm just going to take out my calculator and type it in. 12 math, move it over, 2, 3, enter. We get 1,320. Now if you want to do it step by step with the formula, I'll show you that right now. So the formula is the same as 12 factorial over 12 minus 3 factorial. What I'm about to show you, I haven't shown you yet. It's going to be a little bit a shortcut way. 12 factorial, 12 minus 3 is 9 factorial. Watch this. This is the same as 12 times 11 times 10 times 9 factorial. And the reason why I do that is because I have 9 factorial on the bottom, and guess what these 9 factorials do? They cancel out. And what is 12 times 11 times 10? 12 times 11 times 10. 1320. So you can do permutations. Watch this. There may even be another way. We have 3 different jobs. So I'm going to use 3 different blanks. How many people do we have for the first job? Well, there's 12. So when you assign someone, 1 is out. How many people are left now? 11. So when you assign that one, a second person is out. How many people are left for the third job? 10. And when you do this, this is a fundamental accounting principle. You multiply it out, and we get the same thing we get over here. So you may actually want to do the fundamental accounting principle. It actually makes more sense, by the way. So however you do it, it's totally up to you. So watch this one. We got 4 offices: president, vice president, secretary, treasurer. 1, 2, 3, 4. We need a president, a vice president, a secretary, and a treasurer. We got 15 people total. And one person can't be all 4, or can have more than one office. So, how many people do we have to be president? 15. Once you have a president, how many remain? 14 remain to be vice president. When you have a president and a vice president, how many remain to be secretary? 13 remain. Once you have those 3 positions, how many people remain to be treasurer? 12. So you can just do that. 15 times 14 times 13 times 12. 32,760. Or you could just recognize that if you assign one person to be president one day, then the next day they might be vice president. That's a different arrangement, a different ordering, which means the order is a big deal. Which means it's a permutation. The reason how it might not be a permutation is if you have 15 people and just choose 4 people to be on a committee, don't hold office, but just be on a committee. It doesn't matter how you arrange those 4 people; they're still the same 4 people. But once you give them a title, it changes their order. It changes who they are. Things become more important. So if you use permutations, it'd be 15p4. And then if I take out my calculator, do 15 math, move over 2, 4, and we get 32,760 that way. So how you do it is totally up to you. The blanks actually make more sense when you think about it, but if you like permutations, that's fine also.